So this was a pop quiz which was related to density, moment, momentum, energy, and power MCQs. In the first question, the diagram shows a dimension of a solid block with a mass m, and the dimensions are given p, q, and r, which expression is used to calculate the density. So if you want to calculate the density, density is mass present in a unit volume. So density is mass divided by volume. So mass is m, but what about the volume? The volume is length, width, and height, like p, q, and r. So we just multiply q with r. When we multiply, we get the density. So which expression gives us the density? It is m divided by pqr. So that's why option B is the right answer. Moving on to question 2. In question 2, a wheelbarrow has a weight of 140 newtons, which vertical forces needed to support the wheelbarrow in this position. So whenever you see such question in which there is a turning effect, so you will always use the concept that the clockwise moment is equals to anti-clockwise moment. And to solve these questions, first thing you have to identify the point of rotation or a pivot. So what is the point of rotation, around which point this will rotate? So this is the point around which it will rotate, clockwise and anti-clockwise. So this is a pivot. Weight is acting downward here. So which direction weight will cause a rotation? That will be a clockwise rotation. And this upward force, which direction it will cause a rotation? It will cause an anti-clockwise rotation. And we always take a perpendicular distance. So here the weight is there, which is causing a clockwise rotation. Weight is how much? 140. So this force is 140. So it will be 140 times the distance from the pivot. How to know the distance from the pivot? If the total is 1.4 and out of 1.4, the distance between weight and force is 0.8. So how much is this distance? So 1.4 minus 0.8, that's equal to 0.6 meters. So this will be equals to 0.6. So weight is 140 and the distance from the pivot is 0.6. Because we always take a distance from the pivot to the force. And anti-clockwise moment is caused by the force F, and the distance from the pivot is how much? That is, total is 1.4, so we write 1.4. Now we simplify 140 times 0.6 divided by 1.4. So when you simplify, you will get this as 60. So P will be the, A will be the right answer. Is it clear, this question? How we solve this one? Anyone having a doubt or question in this? Okay. So whenever you see such question in which there is a turning effect, first thing you identify the pivot, then you find the force which is causing a clockwise moment, then find a force which is causing an anti-clockwise moment, and then evaluate, like compare them. Whenever we are solving such question, we always assume that the object is in equilibrium or it is balanced. In question 3, a car is traveling around a circular track at a constant speed. Which direction the resultant force acts? So whenever object move in a circular path, the resultant force is always acting towards the center. So B will be the right answer. So without you don't need a calculation. If the car was at this position, what is the direction of resultant force towards the center? Car is at this position, direction of the resultant force is towards the center. So all the points, the result, whenever object move in a circular path, the force is needed to change the direction, and the direction of resultant force is towards the center. This question is related to momentum. The diagram shows a part of a hose used by a firefighter, 15 kilogram of a water. So the previous question, as a car was moving in a circular path, so there's a frictional force that is directed towards the center. If that was like planet was there, any like moon was there, or any other planet was given moving around the sun, then there will be a gravitational force. The diagram shows a part of a hose used by the firefighter. 15 kilogram of a water flow through the hose each second. So time, each second means time is equals to 1 second. Which force is applied by the hose to the water? So the formula, how we relate or how we can calculate the force, the change in momentum or impulse is force multiplied by time. And what is impulse is force into time, or impulse is also change in momentum, which is mv minus mu. If we need the force, so force is equals to mv, the final momentum minus initial momentum divided by time. So the final momentum, the mass is 15 kg, and the speed is 6, so 15 multiplied by 6, that will be 90. So the final momentum is 90. What about the initial momentum? The mass is 15 kg and the speed is 1, so 15 multiplied by 1, that's 15. And divided by time interval, so it will be 90, the final momentum, minus the initial momentum divided by time, which is 1. When we simplify, this will be 75 divided by 1, or we get as 75 Newton. So when you have the mass, you have the initial and the final speed. So you can use the concept of momentum, that rate of change in momentum is equals to applied force. So it is important that you learn these formulas. I already shared the formula sheet with you. So you have to memorize these formulas. Is it clear? Question 4?
Clear.
Moving on to question 5. Brakes are used to slow down a moving car. Into which form of energy most of the kinetic energy is converted as a car slow down? So as a car slow down, its kinetic energy will decrease. So if its kinetic energy is decreasing, what form it has converted into? Not a chemical, because like chemical energy, food or fuel will have a chemical energy. Elastic strain energy, if an object deforms, changes its shape, size, length, then elastic strain energy. They did not mention anything related to sound, so it's not sound, so it is a thermal or heat energy. That's just what happened. Like if you apply brake on a moving car, a car is moving and we apply the brake, what we find that the brake shoes or the disc brakes, they become hot because of the friction. So most of the kinetic energy is converted into heat energy. An object has a kinetic energy of 200. A constant force of 190 Newton is applied for 10-meter distance. What is the final kinetic energy? So example, there's a moving object. There's a heat can produce fire as well. That is what happens sometime. If the it can produce, because of the friction, it might produce a fire. That is what happened, like rubbing the two dry sticks together can produce fire. That because the heat energy, enough temperature rise, so it can produce a spark or a fire. So they mentioned the car was, an object is moving and it has a kinetic energy of 200 joules. And then the resultant force is applied in the direction of the motion. So if object is moving towards right, we also apply a force towards right, a force of 190 Newton. And for how much distance is it applied? For 10 meters. So force is applied, force of 190 Newton is applied for a distance of 10 meters. The question is, what is the final kinetic energy? So what is the final kinetic energy? Already it has 200 joules. So the total final kinetic energy will be the original kinetic energy plus the work, extra work which is done. If we are doing a work done in the direction of the motion, then we will add to get the total energy. If we are doing a work done opposite to the direction of motion, like example, if the question was, we are doing a work done opposite to direction of motion. So in that case, we'll subtract. As I mentioned, it is in the direction of motion. So kinetic energy is 200 plus. What about work done? How much work is done? Work done is force into distance. So force is 190 and the distance is 10. So work done is 1900 joules. So 1900 joule of work is done. So when we find the total, so it will be 2100 joules. So 2100 joule will be the new kinetic energy. So object is already moving and we applied extra force to move object faster. So its kinetic energy will increase. That's why D will be the right answer. Is it clear discussion?
Clear, sir.
In question 7, the statement describe what happened when the power of a machine is increased. So, which statements are correct? The work done in given time decrease. Look, we have the power is work divided by time. So if we are increasing the power, the work done will increase, should increase, not decrease. So this is wrong. The work done is increased, that's right. And if we increase the power, the time will decrease. The time to do the given work done will decrease. That's true. So power increases. If we increase the power, it means like more work is done in a short time. So power is directly proportional to work done and power is inversely proportional to time. Short time, more power. More work done, more power. So if a power is increasing, it means the work done will increase and the time will be shorter. So option C will be the right answer. So this was a pop quiz 16 related to density, momentum, moment, energy, and power.